Hello students, welcome to Physics Pathshala. In last class we have studied what are the units and different systems of units. Extending that what you have studied, in that class we found out what is physical quantity, when it is measured, it is compared with its unit. That means measured value is some numerical times unit. Unit, it was specified to each physical quantity. Physical quantities are certain derived quantity, certain fundamental quantities, and other derived quantities. Unit of these fundamental quantities were fundamental unit, and derived quantities have units. Unit of derived quantities are derived units. We had assigned fundamental unit or unit to these fundamental quantities. Fundamental quantities we had mass, length, and time. Mass, length, time, and their units in different system were different units. In MK system, length unit of length was meter, unit of mass was kilogram, and unit of time was second. Now we're extending this unit to dimension. This dimension will be linked to again physical quantity. We'll be able to find out dimension of his fundamental quantities, and then we'll be able to find out dimension of derived quantities. We have studied what is this physical quantity. Physical quantity we have referred those terms that will be used in physics to describe describe laws in physics and can be measured. Two things. Physical quantity should be measured. We should be able to measure that physical quantity or that quantity. Then only it will be termed as physical quantity. And those terms, those are used in mathematical equations to describe laws in physics or to understand physical phenomena or nature or natural phenomena. Those terms will be termed as physical quantities. We had fundamental quantities, mass, length, and time. Like we had unit for each fundamental quantity, now we'll assign dimension to each fundamental quantity. Dimension, the word indicates it gives information on dimension of any quantity or any physical quantity gives information about its quality, about its physical behavior. For mass dimension, we have assigned symbol m. For dimension of length, we have assigned a symbol L. And for dimension of time, we have assigned letter T. There is, these are the first letters for mass M, for length L, for time T. These letters are assigned to describe dimension of any physical quantity. That means dimension is expression. Dimension of any physical quantity, dimension of any physical quantity is its expression in terms of fundamental quantity and expressed within a bracket where this fundamental quantity M, L, T are given their powers or exponentials. Let it is A, it is B, and it is C. This indicates dimension. Dimension, that means the quantity expressed inside a bracket, square bracket. Inside that square bracket, the fundamental quantity is raised to its power or exponential. That means dimension is nothing, it is the exponentials or power. It is dimension or power of fundamental quantities which represent that physical quantity. Dimension of a physical quantity is the power of fundamental quantities expressed inside a square bracket. Let us take some examples. Suppose we have a physical quantity, that is force. We know it is not fundamental quantity, it is a derived quantity. Now it can be expressed in terms of fundamental quantities given their powers. Force, we should know its mathematical formula. Mathematical formula of force is mass multiplied with acceleration of that moving object. That is mass into distance per second square. Already you had calculated unit of force unit of force is unit of mass kg times unit of distance meter per second square. Here is a time square. Now, unit of force is kg multiplied with meter per second square. We are given its name Newton. This is the unit. Now, once we will find out dimension of force, instead of taking unit of mass, we will be taking dimension of mass is m. Dimension of distance, that is termed as in length L, and for time it will be T. Here M power 1, L power 1 and T power minus 2, and all are expressed within a square